Welcome to the video. This video will be about, we'll be talking about slope stakes and reference points. There's some material that in the previous video I had asked you to go through, and that's what we're going to be talking about on this video is that material. Now what you see here is a profile of a road. And let's see if I can read all this. It wants to introduce, let's see from the beginning, and the performance of your duties as a grade checker becomes necessary to mark lath with more complex information than simple cut and fill dimension. We've already done that. It is your job to determine the correct information, then write it on a lath in a manner that is useful to construct a project. There's 12 pages we're going to go through, it says, and they're all going to be devoted to helping us understand how to interpret these stakes. We'll be looking at just a snapshot of a plan. In this case, it's a profile. Two terms, I guess you might say. I guess you might say. Sorry about the phone call. There are two terms that I don't think you need to introduce. One is a hinge point. This is a hinge point right here. The other is a flow line. This is a flow line right here of a ditch. So their definition of a hinge point is the point at the outer edge of the shoulder where the roadbed intersects the side slope or the end slope right here where this is the roadbed. This is the center line of the roadbed, and it's sloping. I can tell you right now because they're doing a hillside cut. It's sloping into the inside, and they do not want water running off the outside because of erosion. Like if you've ever been into the mountains, you'll notice that the water drains into the mountain, into the back slope in this case, and it drains down the mountain, of course. Sometimes it looks like it's going uphill, but this would be this, you could call this an end slope, but we do not want water draining off of this side. We want the water going all the way into this flow line of the ditch, which you would be graded so that will drain downhill. This, of course, is the back slope. This is the original grade. It goes down like that. That's where we're starting from. So we're looking at this. It's giving us a hint here. Offset stake, we've talked about that. The toe stake, and it's giving us a little information here. Fill. This is going to be a fill. It's telling it now. There's not much information on here that can be calculated. This is just a description of the profile that we're looking back. Here it is. So it would be a fill of a certain height at 2 to 1 to the hinge point. And I'll get into center line and double line later. If it was a single line, there would be more information telling us a fill to this hinge point. And he has another little hinge point right here that is to set back this slope just a little bit so it doesn't drain exactly straight down into the ditch. Could be reasons for that I don't know right now. Slow it down, but I would assume that's what benches usually do. But you can see here, this would be your top stake. You could look at this. It has an offset stake. Now this has got a little bit of dimensions here. This would be a cut so many feet at 1.5 to 1. This would be a fill, whatever this dimension is, fill so many feet at 2 to 1. And you could put, since it's a 2 to 1. You could go ahead and put the horizontal. If the fill was 10 feet, you'd have a 20 foot at 20 feet. That's kind of, you'll see here later, that's kind of up to the grade setter and maybe even the, the preference of the contractor. So that's what we're going to start with. Center line of the roads right here. Now it looks a little weird going out here that far, but this is your center line. This would be somewhere in here. They'd have a bit of a shoulder, but not much. And then they would have the slope going down the side of the mountain. But once again, minus 2%, that means a fall. So the water would be draining into here. Again, on these hinge points, the point on the outer edge of the shoulder where the road bed intersects with the side slope, and the elevation of the water carrying surface is the flow line. That would be, in this case, talking about the ditch here. There wouldn't necessarily, even though the water's flowing this way, it would be sheeting. So that's a whole lot different than streaming like the water would be doing here. So this should give you an idea of what we're going to be looking at. Different views of this profile, not this profile, but different profile views with some calculations on them. And we will proceed through all that. Slowly but surely. We're at figure 86 right now, and we're going to jump right into double line slope stakes, single and double line slope stakes, and let's see how they define them. Slope stakes are written in two distinct forms depending on, it says personal preference, but it'll be either the contractor, and if it's a state job, they may not want you to, especially a road, they may not want you to use the double line because the chance of error are greater, and when you're referencing from the last point that you've designated. The two methods are known as single line and double line. There's a great difference in the two, and you'll need to learn to read each method. So, characteristic of the single line method is all horizontal and vertical data are from the toe or top stake. Characteristics of double line method, each step is relative to the preceding step, The difference will become obvious when comparing the two methods from examples in the following. In figure 87, the fill to the hinge point is 5 feet. That's going to be down here. Let me go ahead and read that. From the toe stake, with this being the toe, the fill is 5. And from the toe stake with a horizontal distance of 15, as you can see there. But on the stake, you could say fill 5 at 3 to 1. You wouldn't have to put down 15, but most grade setters will. A lot of surveyors won't because they'll want you to calculate that and take a little load of them. But we know to use this right here, you got a 2% at 20, what is that? 20 feet. So what is 0.02 times 20? That's 0.4. So that tells you right here we have a 0.4 rise. So this could be fill 5.4 to the center line at 15 and 20. I'm adding this in my head at 35 feet. We'll look at the stake here in just a minute. Here is your hinge point. Here's the center line of the road. This is the 2% crown that are on most roads, and this will be your end slope going back down. This is your original ground. This says toe surveyor stake is what they're saying. This is your reference in this case. And again, here is the existing grade, the original grade. Now, they went ahead and calculated 2% times 20 like we did here to come up with the 410. So let's look at what they put on the stake. This is your single line. This is your double line. Now, we're not having offsets right now. We're going right straight from the toe. So this is the uh, operation they want you to perform. So we're not going to have the offset, the information stake telling you where to set the toe stake. The toe stake is already set, and you have the information from the information stake. So from the toe here, I want you to fill 5 feet at 3 to 1. And then that means from this point, from this hinge point, this is taking you, fill 4/10 at 20 feet. Fill 4/10 at 20 feet, and that will give you the 2% that we need for our cross slope. Uh, how do I know that? Well, then 0.02 times 20 is 4/10. That's how I know that. And that's the way you do the grade. 0.02 times 20 is 4/10, as it says over here in the circles. Thank goodness they're giving you some repetition on the circles. Now let's just put this in our back pocket. This dimension right here. Let's let's think about what that might be. I think it's just helping us out a little bit here. So that takes care of that stake. Look at the single line stake. From this same toe, it wants you to fill 5 feet at 3 to 1. That's the same thing, 5 feet at 3 to 1 to the hinge point. Now, it's going all the way to the center line. But where do you have to start? Again, since it's a single line, you go back here and you fill 5.4 feet at 35, which I kind of said a while ago. There's 5 of it, and there's the 4/10 in addition that came from the right here in this other situation. That's where the 4/10 came from. Remember, it was this is going to the center line. So from here, we filled 4/10 up to the center line. Uh, Hope I'm not going too fast. I wish there's a way you could raise your hand. I do have a telephone, and if you just completely lost, just call and let me know, text and let me know. I don't know how much time we can spend on helping you get caught up, but we'll give her a shot if you'll tell me what you don't understand. Okay, so back to the single line. Fill from the toe, same place, fill, look what it says here, 5 foot 3 to 1, and it doesn't say and then, it just goes right straight to the center line information. Fill 5.4 from here, there's the 5, and there's the 0.4. That takes you to the center line at 35 feet. So they didn't give us a straight shot, and they didn't want to the center line. So it's fill 5.4 at 35. There's 15 and there's 20, and that's 35. Any questions? Where did you 5.4 come from? This 5 and this 4/10. This is a rather simple one. Now this right here is just letting you know that using this profile, and this is just dotted lines to help us out to plot these things. It's not 5 foot when you're figuring height here. The height, it's 5.4. They're just reminding us that. So let's read a little bit about this. Uh, let's read on. On a single or double line, the first data is the same, but all subsequent data are different. On the single line, all data are from the surveyor stake, slope stake, reference stake, or top stake, depending on where you're starting. While on the double line, each data follows the preceding one, and that will be your stake will be, in this case, cut 10 feet at 15 and then level for 10 feet and then cut 6 feet to here at that's, I'm guessing 9, because it's 1.5 slope. Yeah, well, I'm not guessing, it says 9. And then, so let's see what it says. On the right hand side, you have the way I've been doing it just now. Cut 10 feet at 1.5. So we're right here, we're going to cut this 10 feet, 1.5, which gives us 15. 1.5 times 10 is 15, right? So they're just going to say at 1.5 to 1 to bench. This is the bench. So let me not get ahead of you there by throwing in 15 when they didn't do it. I probably would have. So cut 10 foot at 1.5 to the bench, but you would have to know that that's 15 feet. You would have to know that you're going to put your bench stake up here on this ground 15 foot away, and then you're going to have it cut down until you get here, or wherever you're sitting here. It may be over 15 feet since you're on original ground, but you're going to cut down to where it would be if you followed these dimensions. Okay, and then level. That means the bench itself. And once again, I'm going to ask you to just look at the middle of this and picture this going away from you and coming towards you. The water's going to go down, and it's either they put this bench in here for a reason, probably to slow the water down or to divert it. This level spot coming toward us may be going down, going away from us may be going up, so the water may come down, hit this, and go on our z-axis, let's call it, either downhill in this direction or downhill in this direction. But it won't. They're preventing it from going rushing all the way down the side of the slope for various reasons, probably mainly erosion. Uh, so once again, on this side, let's go over this one more time. From the top stake, we're going to cut 10 feet at 1.5 to 1. And that's going to put us 15 foot out and 10 foot down. And then for 10 feet, we want to stay level. But remember, we're going toward us and away from us. This is a profile. And then level. And then cut 6 feet at 1.5. So we're going to cut this 6. From here, we're going down 6 at 1.5. And being 1.5 is going to put us 9 feet out this way. So we have to calculate that as the grade setter, because they didn't say cut 6 feet at 9. They said cut 6 feet at 1.5 to 1, which would be 9 foot horizontal. Would it not? Yes, it would. Go back to your circles. And then we got to come back up a little bit and then fill 3/10 at 10 foot. There, it gave us the 10, right? It didn't say, where am I? Fill 3, it said fill 3/10 at 10. It didn't say fill, what am I trying to say? 3%, because that's what it would be. It said fill 3/10. That's what 3% would be, 3/10 at 10 feet. So it gave us our information, and that's to the center line. But over here, we've got the same thing where this is going to be level. Notice the things are the same, really. This is exactly the same wording. This will change in horizontal and maybe in cut depth, because they're all looking like cuts here. So we're going to start from the beginning here. Cut 10 feet at 1.5 to 1. That's this. We went over 2 or 3 times. This next one doesn't tell us where we're going, but it's telling us to cut, where am I reading? At 25, so that's 15 and 10. This is taking us here. This took us to the bench. This is keeping us level. Cut 10 at 25. The 25 takes us out from 15, 10, that takes us horizontally 25 feet. And since it says cut 10, it's the same as this 10. So that makes the bench level. It's just getting us there in a different way. Let me say this again. This started where this started. It has the same information on it, so it takes us to the same point. Now, we want to get to here from single line, so we got to get to here, but we got to get to here from here. So we've got to cut 10 feet just like here, and we want to say several at 25. That's that 10 and that 15, and that'll put us right here level with this bench where the bench starts, and this is our hinge point going down to the I would think the flow line. uh, this would be the back slope and this would be the road. So that got us here. Now cut 16, what is that? There's 10 and here's 6, so that's the cut 16 at 34 feet. So here's 15, 25, and 9. Where did this come from? The 1.5 to 1 times 6 is 9. The 1.5 times 10 is 9. And continuing on here, sorry, let me go back. We have established this point right here with this information. The cut 10 and 25 puts us here. Now we want to get down to the hinge point, and that's what they're calling the hinge point right here, what I call kind of the ditch, but this is from closer to the shoulder going into the ditch. So it's going to say cut 16 feet, and that comes from this 10 right here and this 6 right here, and 34 comes from this 15, 25, and 9. That's the 34. It puts us here at what they're calling the hinge point. This will take us to the center line, as this took us to the center line over here. So this is a cut of 15.7. We want to be going to right here, I believe. Yes, the center line right here. So this tells us to cut 15.7, but we have to do that from here. So let's see where we got there. There's 10, and let's see if I can come up with 10. Here is 6. That might be in 3/10. So 16, let's see, 16. Here's 10. Here's the 6. That puts us 16. So that gets us down here at 34. So that's 15, 25, 34. So that puts us to the hinge point. Now, for some reason, we're 3/10 lower for whatever, and that's going to reveal itself coming up, I think. So now we're going to get to the center line. That put us at the hinge point, this one here. Now we got to go all the way back up here, and we got to cut 15.7. Here is 10. Here is 6. I'm saying for right now, that's 16. That's too much. Cut 15.7. Here's 10. That's a given. That's 16. That's 6 to right here. So the 0.3, hold on. That allows us to have, by cutting to here, allows us, this would be, but I'm not making sense here. I'm not happy with this. 10, and they're calling here 16. Oh, wait, calling here 16 at 34. So 34 would be 15, 25, and 9. So that puts it here, but not here. What does the last thing say? Cut 15, 7. That leaves that 3/10. Cut 15, 7. Cut 15, 15, and 7/10. 10, 16, less 3 is 15, 7. So they want us to get right here. And they want at 44. Now that looks a little weird, except this is going to bail us out right here. We have 15, we have 25, and we have 6 is 25. Let me get my calculator. We do that again. We got 15, we got 9, so that's 24, and let's see, 9, 15, 25, 34, 44, 44. Whoa, goodness sake. You can see if you got a pencil and paper right beside you, it's much easier to do that. But that's the theory of it all. Now I'm not stopping. I want to go through a couple more here. Uh, Again, uh, it's just that we had to do everything over here. We had to start each time. Excuse me, right here. Everything over here, we had to start from here, and then this became our reference to here, and then we referenced to here, and so on and so forth. The foregoing examples illustrate the two basic methods of writing slope stakes. As illustrated, there's a substantial difference in interpretation of a slope stake when a single line or double line is what it is when it's used, when a single line or double line is used. To ensure complete understanding of the two methods of writing slope stakes, the following sample problem is presented. And it's telling us to see this right here. Now we've got a little note up here. Got to look at everything uh, that that's available to us. What's available? Which way are we going? Uh, this is giving us the 0.3 right here, right away. It's just not showing us any uh, any circles to use. But what they did to get this is they took this 15% and they multiplied it times 0.02, and that gives you 3/10. So we got to be 3/10 higher, and I'll bet you, yeah, that'll give us the 2%. That's the cross slope. And these are cross sections of a roadway we're looking at, by the way. So let's start with the double line. That's the easiest. And we're going to be moving left to right. I can see that now because here's our reference point, our reference stake, right here, the toe stake. So, no, that's not. Is that right? Yeah, yeah. That because we're going left to right. So here we say uh, fill 3.3, and there's that fill at 2 to 1, and 3.3 times 2 is 6.6. That's our horizontal. So that gives us to this point. So quickly, what is that uh, slope? 2 to 1. You could divide those and you get 2 to 1. Horizontal divided by vertical, 6.6. 6.6 divided by 3.3 equals 2. 2 to 1. That gives us a 2 to 1 slope. Now, and then, well, let's just follow back and forth, see how that works for us. Over here, it says the exact same thing. So it's going to the exact same place. Now, things may change. And then over here, it says level for this 10 feet. And then level. So from here to here is 10 feet and it's level. Now, here is where we start changing. We got to fill the same 3.3, but we got to do it at 16.6. Why in the world do we have to do it at 16.6? Because we got to get here, right? So we're going to fill this 3.3 at 16.6, and that's going to keep this level, but it's going to be 16.6 away. There's 10 of it, and here is 6.6 added to that. So fill 3.3 at 16.6. It's going to put us at the same place. Fill 3.3 at 2 to 1 to the bench, and then 10-foot level. So both of these were at the same place. Can't lose my picture. Let's jump over here. Fill 8 foot. Where in the world's that coming from? That's always a surprise. Fill 8 foot at 1.5 to 1. Oh, and then, because we're here on both sides. We're here now on both sides. I'm right. I know I'm right. Yes, there's 6.6 and 10. So we're here on both sides. Now we're going to go from here. We're going to fill 8 because it says and then fill 8 at 1.5 to 1. So 8 at 1.5 to 1 gives us a 12-foot horizontal and puts us at this little hinge point where the elevation kind of change or the slope changes. But let's see what it says over here. This is scary. Fill 11. When you do this ad lib and you see this things like this, you go, what? So fill 11.3. Let's see if we can find 11.3. Here's 3.3 and here's 8. There you go. 11.3. So we got to go up to here from this stake. We're going to be going to this level. We don't know exactly where, but it's going to be 28.6. So is that where we want to be? Here is 16.6 plus 12. 16.6 and 12 is 28.6. So now we caught up with each other. Both here and here puts us here. And then now we're going back to, we got to get to the center line. And then fill 0.3. There it is, fill 0.3 at 15. And it just, we're 15 foot away. Fill 0.3 at 15. Now let's tackle this guy. Fill 11. Let's see if we can find 11 first. Here is 16.6. Here is 8. 16.6 and 8 is, I gotta calculate, guys. Hold on. Let's go down here. We're going to the center line, 11.6. And we're going to where this will be, because he's leaving the hinge point and he's filling 0.3 at 15. So that's going to put this guy here. Now, will this guy get here? So we have 3.3 and we have 8. That's 11. 3, and we have 0.3. That's 11.6. Hallelujah. That puts us at the same place. So you see we got there measuring from each preceding point to the same place with all the hinge points and level benches. Everything included, we ended up with the same exact profile, either using the double line or the single line. Now, which one is more accurate? Why wouldn't you use the double line? Because it seems like it'd be easier, than the other line. Because there are cases here where you got to pull the tape measure 43 feet, 28 feet. When over here you're just pulling it 12 feet, 15 feet. But if you make an error here and an error here, it's just accumulation of error. So this is the more accurate way of doing a roadway. And if it's a state highway, you're probably using single line. If it's a road in a subdivision, you'll probably use this. Let's continue on. We don't want to quit yet. What does this say? Slope information is always provided on an offset stake rather than a toe or top. Slope information is always provided on an offset stake rather than a toe or top stake. Now, that they're talking that we've seen these before. We were doing these on our last video. This is a reference point to slope stake. It's just in different terms. The other one was called a survey information stake. It's the same thing. It's going to tell you where to set your toe. So let's start again. Slope information is always provided on an offset stake rather than on the toe stake, because you don't want anything knocking it over. So it doesn't need to be close to the work, which is likely to get disturbed during grading efforts. While no rule exists on how far out the offset, it should be set from the toe or top at least 10 feet. And they consider that normal. So up here, this toe stake would really have an offset stake back here out of the way with the information to put on the toe stake, as we saw in our previous video. And it would have one indent thing on it, and all the information would be on the toe. So I want you to understand that. That's what they're saying here. They're using an offset stake. What did we just do? It's time to go here. So figure 90, that's this figure, illustrates how to mark an offset or a reference point. I call it reference point. It's a slope stake. Some people call it reference stake. Some people call it offset. But you'll know where the information stake is and what title it's gonna have. So it illustrates the data that's presented in the illustration. So all we're doing right here, these two are doing the same thing. I just quick glance, maybe not, but this stake, this is said to be like government stake. In 10 feet, I want you to fill 1.2. So in 10 feet for wherever I am, and they're saying I am here, from this point, I want you to fill 1.2 and set your top stake. It would be here. And then that'll tell you, in this case, probably cut, whatever this slope height is. But reference point, 10 foot away, slope stake has all the information down here, like we've been kind of looking at up here. Here's another example. This means 10 foot offset. That's all. Cut 0.8. So I'm starting here and I want you to drop down 8/10 and go out. There's the 10 feet away from me, and set your top stake right here. And then it's telling you what the slope is. Cut 7 there, right there at 2 to 1. So that would be a 14-foot horizontal. And then it's cut, what does it say? And then fill 0.6 at 12, which would be 0.5%. It would be 5%, 0.05. So it's taking you all the way to the center line with just a couple of stakes here. I mean, couple of destination points here. So typically it's written as followed. Did that. It'll all the information you need on your toe stake will be from here down, usually on these reference point to slope stake. So that's that video. Lot there, going a little fast. Had a little interrupting with the domestic animal here that I had to chase out. And but if you have questions, now for goodness sakes, let me know. If I went too fast, if I got you confused, I can get you unconfused, I believe. If you're good, you're good. So we're going to stop the video right there. And that gives us our reference point slope stake video for week 7. And now we should be just about ready for the assignment. Before you do that assignment, be sure you have watched this video. Go back if you don't understand anything before you do that assignment, because you'll be graded on that week 7 assignment. All right, that's it for now.